So, very good morning, students. So, welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 8 students so far for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8th. Our ongoing chapter, heat, and today we are entering into the session number 4. So far we completed 3 sessions in understanding the what is heat, what is temperature, and what are the some properties. For example, we learn about what is heat, what is temperature, and you have seen the difference between them, temperature and speed. Of course, we can see what are the sources of heat that we'll discuss now. It's not there for you. You can recall source of heat, right? And of course, you can say conversion of heat. And of course, we have thermal expansion of heat. Thermal expansion. That we are discussing about the thermal expansion in the last class. So what is heat? So before going for today's session, where we continue, where we stop in the last class. But before that, let us recall what terms we learned in the chapter. So first thing, of course, the core topic, that is heat. Heat is a form of energy, form of thermal energy, you can call it thermal energy, which flow from hot body to cold body. It flows from hot body to cold body. So because of the heat, which is the cause, body will get the temperature. That is, either body may be hot or cold. The degree of hotness and coldness of the body is termed as temperature. Heat is measured in joule because it's a form of energy, and also measured in calorie. Right? 1 calorie is equal to 4.18 joule. Very important numerical value. Whereas temperature is measured in Celsius or Fahrenheit or Kelvin. So sources, heat can be from where heat is coming. We know the major source of heat is our sun. Sun is the major source of heat. Of course, apart from the sun, there are so many things are there like fuels, petrol, diesel, kerosene. They are also source of heat. Right? So many sources, wood, charcoal. When they are burning them, you can get the heat. So this heat produced can be converted into various forms also, or you can get the heat from various forms. For example, when you pass electricity to the iron box, we can produce the heat. Heating effects of electricity. Even room heaters are there, water heaters are there, geysers, or even stoves are there, heating stoves, electric stoves. Where all these produces the heat from various sources. So from various sources of energy, we can get the heat also. So, but whenever any body is heated, whether it is a solid, liquid, or gas, when a body is heated, they undergo expansion. Solids also undergo expansion. Liquids also undergo expansion. Gas also undergo expansion. But the difference is, as the solids will have a geometrical shape, a regular shape due to the perfectly arranged molecules. They have length, they have breadth, they have height. So because of that, they undergo 3 types of expansions when compared to the liquids and gases. So today we are little more deep. We'll go about the, we have seen already temperature and heat difference also. We have seen about the thermometers. There are various types of thermometers, various sales of thermometer scales, and the relationship between them, Kelvin, Fahrenheit, and Celsius thermometer, as well as Reaumur also we have seen, and the relation how to convert the one value into another value. from that relation. Right, C by 100 is equal to F minus 32 by 180 is equal to K minus 273 by 373. These of relation, you can convert the any system of scale, any scale into any scale temperature. Okay. That we have seen. Then when you enter the expansions here, I'll show some video also on this. Once again, whenever a solid is heated, it expands lengthwise, which is called linear expansion. It expands area-wise, which is called areal expansion, which expands volume-wise, which is called cubical expansion or volume expansion. Like that, as the solid is having a perfect geometrical shape, it undergo all three kinds of expansions. Whereas liquids only will go under, liquids and gases will undergo only volume expansion because they does not have any shape. They just occupy the shape of the container. Okay. So that is what total chapter tells about expansions. Expansion in the solids, liquids, everything. Okay. Liquids also you can see. That we'll see before going for that. Let me show you one video on the expansions. Then we'll go for the further explanation. Right.
Thermal expansion. Most materials expand on heating while contract on cooling. Displayed here are the examples of thermal expansion. A completely filled and tightly capped bottle of water cracks when it is heated due to the expansion of water molecules. Lid of a metal jar can be removed by dipping the jar in hot water. This is because the metal lid expands due to the absorption of heat. Did you know that the wing panels of high-speed aircraft when on ground fit together so loosely that fuel may leak out of the wings? But once it starts flying with a speed equal to 3 times the speed of sound, the panels expand to make a perfect fit.
High-speed aircraft.
The expansion of solids is due to change in interatomic separation. Let us try to understand thermal expansion qualitatively on the basis of molecular theory.
See,
let us visualize the forces between the neighboring atoms in a solid by imagining them to be connected by springs that are easier to stretch than to compress. Each atom vibrates about its equilibrium position. When the temperature increases, the energy and amplitude of the vibration also increase. The interatomic spring forces are not symmetric about the equilibrium position. They usually behave like a spring that is easier to stretch than to compress. As a result, when the amplitude of vibration increases, the average distance between molecules also increases. As the atoms get farther apart, their dimension increases. The thermal expansion of solids is of 3 types, namely linear expansion.
Linear means lengthwise. Superficial means area-wise. Cubical means volume-wise.
Superficial expansion and cubical expansion. Linear expansion. If the change is only in the length of the object, then the expansion is called linear expansion.
Very important point, right? The first case is linear expansion. You can see here.
Let L be the length of a rod at some initial temperature T. When the temperature changes by delta T, the length changes by delta L. It is found that if the change in temperature is not so large, say less than 100 degrees Celsius or so, then delta L is directly proportional to delta T and its original length L. Therefore, delta L is equal to alpha into L into delta T, where alpha is the constant of proportionality called the coefficient of linear expansion.
Alpha.
The unit of alpha is per degree Celsius or per Kelvin. Think it over. Superficial expansion.
Second one. Area.
The change in area of a solid is called superficial expansion. If A is the initial surface area of a solid and delta A is the increase in surface area due to a temperature change delta T. Then increase in the surface area is directly proportional to the original area and increase in temperature.
Increase in
Delta A is directly proportional to A into delta T. Delta A is equal to beta into A into
beta
delta
will get
T,
here. Alpha,
where beta is the constant of proportionality called the coefficient of superficial expansion. The unit of beta is per degree Celsius or per Kelvin.
Kelvin.
Cubical expansion. The
Area.
expansion in the volume of a solid is called cubical expansion. Let V be the initial volume of a solid and delta V its expansion due to a temperature change delta T. Then the increase in volume delta V is directly proportional to V into delta T. Therefore delta V is equal to gamma into V into delta T, where gamma is called the coefficient of cubical expansion. The unit of coefficient of cubical expansion is per degree Celsius or per Kelvin. Gases and liquids also expand on heating like solids, but water behaves in a different way. Let us now see what happens when water is heated.
Expansion of liquids you can see.
Thermal expansion of water.
Water.
When water at 0 degrees Celsius is heated, it contracts till 4 degrees Celsius instead of expanding and behaves like any other liquid above 4 degrees Celsius. This behavior of water is referred to as anomalous expansion of water. Anomalous means irregular or deviant feature. Natural consequence of anomalous expansion of water. When the water on the surface of a water body cools down to 4 degrees Celsius, its density increases and hence it sinks. The warmer layer of water from the bottom rises to the surface. This layer cools to 0 degrees Celsius, thus forming a layer of ice. The dense layer of water at 4 degrees Celsius remains in the liquid state, as the ice formed on the surface is a bad conductor of heat and provides a suitable condition for the survival of fish and other aquatic animals.
Right. So this is about the expansions in solids. How it happens? 3 cases, and of course some expansion in the liquid also given. Now it's purely about the liquid. Only about liquids. Undergo only volume, cubical expansion only. No linear and superficial.
When any substance is exposed to heat, it undergoes significant changes due to heat energy. Expansion of a substance, known as thermal expansion, is one of the important effects of heating. The phenomenon of thermal expansion in liquids is different from the one that happens with the solid materials. In this session, we will study about thermal expansion in liquids. At the end of this session, you will be able to explain the phenomenon of thermal expansion in liquids, describe the practical examples or the applications of thermal expansion in liquids, recognize the peculiarity of thermal expansion of water. How expansion occurs? Expansion occurs on heating as the heat energy increases the moment of the constituent molecules. The molecules collide with and repel each other. This increases the intermolecular spaces. The entire structure is enlarged. The substance occupies more area than earlier, and we see this as expansion of the substance. Liquid and solid expansion differs, as the molecular structures of the liquids and solids are different. They show difference in expansion. Liquids expand more than solid for the same change in temperature. The bonding of molecules in solid is more rigid compared to that in liquids, because of which liquid molecules move freely and rapidly, thereby achieving faster expansion than solids.
Fastly they are
The intermolecular distances after molecular collisions are more as compared to those in solids, and thus liquids show more expansion than solids for the same change in temperature. Let us see an experiment that shows that expansion of a liquid increases its volume. Take a flask, fill water up to its brim, and close it with a rubber stopper.
exactly up to the neck.
Insert a narrow tube in the flask through the hole of the stopper. Now, heat the flask and see what happens. Surprisingly, the water level first drops down and then starts rising. Let's see why this happens. On heating, the heat energy first reaches the solid flask and expands the flask. This increases the width of the flask, and this makes water level to drop down. But soon the heat energy rises the water temperature also, and water starts expanding. The water level rises and we can see the increase in volume of water. Thus, we have learnt expansion in liquid changes the volume of that liquid.
That's all. Nothing change. Only volume.
Experiment 2. Though it is evident that thermal expansion of liquid changes its volume, the magnitude of expansion changes for different liquids. Let's check this out with an experiment.
Very interesting.
Take 4 flasks of same size. Fill water in the first flask, liquid ether in the second flask, benzene in the third, and ethanol in the fourth flask. Place all the flasks in a container filled with water and now heat the container. Take flasks. The flasks expand first and the levels of the liquids go down. Later, the liquids start expanding and volume of each liquid is seen as rising with the increase in temperature. The temperature rise for each flask is same. However, the volume increase in all the 4 liquids is different. The ether shows the highest increase in volume. We can say that ether is highly expansive fluid as compared to water and other liquids. Coefficient of thermal expansion. The comparison of expansion in different materials becomes clear with the help of coefficient of thermal expansion. The coefficient of thermal expansion of a material is the value that indicates how much expansion occurs in that material for each degree of temperature increase. For example, coefficient of thermal expansion for ethanol is much higher than that of aluminium, and this shows that ethanol expands more than aluminium when the temperature increase for both of them is same. Liquids and thermometer. The manufacture of mercury and alcohol thermometers is based upon the expansion difference between solids and liquids. Thermometer consists of a glass capillary ending in a bulb shape which is filled with small amount of liquid, either mercury or alcohol, in the form of stained red ethanol. This liquid filled capillary is protected and placed in a calibrated glass tube. As liquids expand at a faster rate than solids, when temperature increases, mercury expands at faster rate than the glass tube. The volume of the mercury increases remarkably for a small rise in temperature. As it flows in a narrow column of a glass capillary, we can see the height of the mercury rising with a little rise in temperature. Thus, thermometers are one of the best applications of liquid thermal expansion. Liquids and engines. Thermal expansion of liquids has an important role in various mechanical engines. Liquids are widely used as a cooling agent
application,
or
in
a
the
coolant that
expansion of
cools down engines to lower temperature. Liquids have better thermal conductivity and their nature to flow helps to carry away excess heat in an engine. In car engines, water
For the
or
water, for
glycol
radiator.
coolants are used to prevent engines from overheating. In nuclear reactors, water or liquid metals like molten sodium or lead bismuth eutectic are used as coolants. Rockets
Cooling.
use liquid propellant films to cool their thrust chamber. Anomalous expansion of water. Generally, expansion
property.
reduces density of a liquid and contraction makes the liquid denser. When the temperature of water reduces from 4 degrees Celsius to 0 degrees Celsius, instead of contracting, water starts expanding. This irregular behavior of water is termed as anomalous expansion of water. In lakes and seawater, as temperature of the surrounding environment decreases, water contracts and becomes denser and denser until its temperature reaches to 4 degrees Celsius. But water reaches to its maximum density at 4 degrees Celsius and its density does not reduce further. This becomes possible because when the temperature falls down from 4 degrees Celsius till 0 degrees Celsius, instead of contracting, water expands and consequently becomes less dense. At 0 degrees Celsius, the surface layer freezes to its ice, but its density remains lower than the water below it and it floats on the surface. The floating ice also acts as an insulation, preventing the freezing of water below it and allowing aquatic life to survive.
Right. So it's a very interesting observations about the expansion of liquids here. We can see how the liquid expands volume wise, especially in water. We have seen clearly expansion of water. What explained there? Okay, expansion of water. That is the last part of this synopsis. So what we have seen today is thermal expansion of solids, where we come across three cases here. Solids expands lengthwise. So whatever expansion, whether lengthwise or area-wise or a volume-wise, for example, if you change in length, when you are heating the solid, the change in length is depends on its original length and change in temperature. What temperature you are changing? Initially, how much length it is there? Based on that, increasing also depends. Initially, if you take 5-meter rod, next 10-meter rod, 10-meter rod will expand more than the 5-meter rod at given temperature. So that is the statement here. So from here, you can write delta L in place of proportionality, delta L. Proportionality use the constant alpha, right? Alpha L delta T. So that is L2 minus L1. Changing, you can write L2 minus L1 is equal to delta L delta T or L1 delta T. This is a formula for where alpha is called linear expansion, coefficient of linear expansion, where alpha is equal to delta L by, if you get L delta T will come to down, L delta T, the formula for the alpha. Similarly, second case, in case of area, areal expansion depends on area, change in area is directly proportional to original area and change in temperature. From here, we'll get the beta. In place of proportional, you can write beta. A is the delta A is equal to beta area delta T. Right. So from here, beta value you can get it. Similarly, third case we get gamma. In case of volume, change in volume is equal to original volume into L delta T. So change in volume is equal to gamma, gamma V L delta T. So what we get here? Alpha, beta, gamma, three constants we got as a coefficient of linear expansion, areal expansion, cubical expansion. That's possible in case of solids. And they have the relationship also there between the three. Because alpha is only lengthwise, beta is length into breadthwise, gamma is length into breadth into heightwise. So they are in the ratio of alpha into beta into gamma is equal to 1:2:3. Because beta is nothing but 2 alpha only. Alpha into 2 alpha into 3 alpha. So alpha, alpha, alpha cancel. So 1, 2, 3. Why 2 alpha? Because length into breadth. Because expansion is same, but at constant temperature. So the ratio of alpha into beta into gamma is 1:2:3. That is given in the relation also here last at the end. Okay. So this is totally about the thermal expansion in solids as well as in the liquids. Liquids also we have clearly seen in the videos how the liquid expand. And there is of course separate special properties there for water at 4 degrees. That also called anomalous expansion of water, which is clearly explained in the video. So alpha into beta into gamma is equal to 1:2:3 is given clearly. Okay. So when you heat the liquid which is kept inside the container, first what happened? Container will heat and container will expand. That's why water level appears to be down for some time. Then when once water started expanding, it will go rapidly, expand rapidly. Okay. So remaining part. So we discuss in the next class about the other parts. That is about the next synopsis. Very interesting about the calorimetry and what is calorimeter, how to measure the heat, what is terminology like specific heat, latent heat. Okay. And what is calorimeter, how it functions, followed by the solid examples. We can close the chapter in one more session. That is total syllabus, the last chapter. Okay. So there is nothing to work with your worksheets, which are levels given in the material. After completing one of the synopsis, you can go for the worksheet level 1, level 2, right? So that's all for today. Thank you, students. Have a wonderful day. Thank you.